I do have a quick,
Go ahead.
I do have a quick question for you. I tried to go into your O'Reilly Labs this weekend and it says that we have a share. Watching your YouTube and matching it with it, I don't have as many shared. I don't know if I was logging in wrong or what.
Okay, one thing I would suggest strongly with that particular, one of the things I've had problems with recently, and I don't know why this is happening, but I strongly suggest when you go into O'Reilly, try using an incognito window or using a browser window that is like in private browsing. The cookies that are being held by that site are causing some issues, especially for me. But let's go here and I'll go ahead and, so you go into current students library. You go down to resources, A to Z database. One of my coworkers was having an issue, but they use it in a different fashion. They use, they have an actual login, but let's go see. So under your playlist, are you not seeing the playlist that I have? So you should see under playlist.
Well, I went over to explore. I think that's what you said. And I did that. Yeah.
Okay. So you looked at shared playlist.
Yeah.
You should see those playlists all across here. These are all the ones that are shared by at Stanley.
Yeah, I was looking at the CCNA materials.
Mm-hmm.
And I thought, yeah, no, that's okay. I thought there were more items when I was on the YouTube one, but that looks.
No, you may have been looking at one of the like CCNP. I may have showed you the CCNP
yes
video. Seeing that there are more items in the CCNP one because CCNP is actually 2 exams instead of a single exam. So under the CCNA, there are just these 3 items.
Okay, then I was in the right place.
Okay, I will tell you this, like I said, it's amazing that we have this entire video course by Kevin Wallace. He's a really well-known figure in CCNA world, but 15 hours. So if you're interested, that's there. I'll also tell you one of the things that's super helpful when we get to the point of taking the exam, if you want to. This book right here is extremely useful, this exam cram, because it will walk you through and let you look at the topics and understand, exactly what's possibly going to be on the exam, what you need to know. So that's another neat little thing there. So, but yes, you're in the correct place. You will, by the way, again, have access to those materials for up to 2 semesters past the end of your last class. So, technically you won't finish your last class with us until into the fall. And even then, if you take another class with us, you may take them longer, but you will have access to this at least through summer of next year. And as long as you have a valid SEC email address, which again, it stays valid for 2 semesters past the end of your last class, you will have access to all those materials, which is, again, a pretty neat little thing to have. I do want to go over this again. I know I've been starting off almost all of our classes with this, but our class will end on July 26th, the CCNA 1 class. The final day, then when I need you to have everything finished up, will be on the 26th. By then, I would like to have you with all of the, and I know it says the 12th here, but you'll see it's changed now. If you go and look, it's actually July 26th. But you need to have all the module exams completed, which are at the beginning of each module item, each module section. I do have your set to let you take it 10 times. You'll need to take the course feedback, which is turned on now, and the written final exam, which is inside of Netacad. Now that exam can only be on for 7 days at a time. It turns off again, I think in 2 days, then I will turn it back on for you. So I'm going to try to keep it on from now on until the class ends. If for some reason you go in and it's not activated, just send me a quick email and I will activate it immediately for you. So, and then the final item is your skills-based assessment. So one of the things I did do is I went into our Netacad class. Well, hold on a minute. I got too many things open here. Hold on one second. I got way too many windows open. Close some things here. There's many windows open. I can't find where I'm at. multitasking at its best. But inside of our class, you'll notice that down at the very bottom down here, you will see your written exam. So your final exam, which is written exam, your final skills exam. And I had actually, why that didn't move? Because I actually moved it just a minute ago. Oh, it's just second cohort. But you'll notice that underneath the final skills exam, it has now moved, but you see it says final skills equipment. I've got this set up where you can upload it once someone has actually submitted an upload, but you complete that exam on NetAcad. So it's a lab on NetLab, excuse me, it's a lab on NetLabs. You go into NetLabs, you schedule it. I would schedule for 4 hours. It's not going to take you 4 hours, but I would do it just to make sure you've got a block of time. And then inside of the exam, you'll notice it asks you to pick one of the networks to use to do your subnetting. And this is the network I want you to use, the 192.168.10.0/24. Subnet A should have 100 hosts, subnet B should have 50. And then each time it asks you for an instructor sign off, you just work through that, because the exam is designed to be used in a classroom, to where I would have you do the first part, sign off on it, second part, sign off on it. And that's how I do with my students. But since you're instructors, we do it a little bit differently. All right. So those items, those major 4 items, are what's left for you to be able to be accredited to do CCNA 1 at your school. Are there any questions about that?
Okay, I'll say I've been working through it.
Okay.
And I'm following what you have in the Word document, but if I wanted to go back and do any of the packet tracers or something just for my own benefit, that's still going to be open? Or
yes, and I can leave the class open, or once you're accredited, you can actually create your own class for yourself.
Okay.
Yeah, once you're accredited, you can just create a class for yourself, and I do that all the time inside of NetAcad. I'll create a class for myself so that I can do just review things. So, go under I'm teaching. Oh, I don't know what this I'm giving thing is that's showing up. Not real sure about that. It just started showing up today. It says I'm managing, I'm teaching, I'm learning. Most of you only have I'm teaching and I'm learning. But I create my own courses all the time so I can look at things. And I'll walk you through next week on how to create a course yourself. But as long as you have the instructor role and you're accredited in the course, you can teach that course. And you can create it locally. So,
because you probably noticed some of the labs I did several times just because I wanted to play with them different ways. And I'm like, okay.
And that's the best way to do it, honestly. And honestly, it's also why I give you so many labs to do, is because I want you to see what the students are going to see. Now, when you start teaching this in your schools, you may decide that you're not going to do all the packet tracers. You're not going to do all the labs. That's fine. So, technically, we like to see you do every single lab and every single packet tracer, but it's not realistic. You also may want to bring in other materials. That's perfectly okay too. You're a university, and we expect you to build your curriculum the way you want to build it. Now, I will say, if you remove too much from the materials, they're never going to pass the CCNA exam. And worse than that, they're not going to have the skills they need to succeed inside of the IT field. So I stress that it's really good to leave and do as many of those labs as you can. But I also understand that you may not do every single lab. And you may have a lab that you've used, if you've taught networking your entire life and you have a really good lab that already covers one of the topics and you like it better, use it. That's perfectly fine. And so that's one of the things you can do. You can upload things in here, and you can create your own links to different labs. Okay. Other questions or other comments? Any other issues? Yes.
On the assignment, the ITN skill, the one that you gave us, where do we need to submit that one?
You submit it right down here at the very bottom. You submit it right here, skills equipment.
Okay.
So you upload it right there. So you will complete it on NetLabs, fill in the document completely, and then upload it here. I will then take your upload and I will go into NetLabs, and I can look at everything that you typed in, and I'll grade your hands-on skills exam.
Okay.
Excellent. Good question. Thank you. Any other questions? The other thing I want to ask and just put out there right now is this. All of you that are, I know Hampton's a new school as far as an academy. Some of you are academies that are coming back online as Cisco academies. We need to start looking at your ASC relationship, because as Cisco has said, they're paying for your support fee for the first year. And so we need to make sure that you've got an ASC relationship in place. Some of you have already signed relationships with us, and that is wonderful. If you don't want to work with Stanley Community College, it is a completely open model. You do not have to work with us. There are other ASCs out there. ESC 11 in Texas, used to be Townsend. Townsend went away today, in fact. And that was the one I've really been working with, trying to get schools from that used to be under Townsend. But there are others around about. So if for some reason you don't want to go with Stanley, you still do need to establish an ASC relationship with some academy support center. We would love to have you with us. Again, we're so excited to be part of this project that we really hope you will pick us, and that we can help you with that process. But we can talk about that with those of you who are main contacts at the academies. Okay. Well, let's jump forward then. Any other questions before we move on?
On the relationship that you're talking about, is that a different application that we've submitted when we started, or?
It is a little bit different. Now, what you've probably done is you've already applied to become a Cisco Networking Academy. You then need to actually pick an Academy Support Center underneath. So when you're underneath, I'll show you an example. So for example, I'm managing multiple different academies. I manage the ASC and ITC here, and also manage just our normal Cisco Academy. So this is just our normal academy that our students go to at Stanley. Well, you'll notice that I have an ASC relationship with myself. Obviously, I would do that. If you don't have an ASC relationship right here, you need to establish one for your academy. And you can click there, and you can actually go and pick your an ASC. So you can find your ASC. And I have a video on how to do this. So if you want that video, just send me a quick email and I'll send you an email. But basically, you can find my ASC, and you can search for us. I just tell people to search for Stanley Community College or Albemarle, North Carolina, either one, and you'll find us. And then if you request us as your Academy Support Center, I go in and I get a little email from you or from the system that says this school is requesting a relationship. And if we talk and we have that relation, we're working on that relationship, I accept it. So we have right now 192 different schools underneath us. As Cisco Academy is actually be 193 now, since I accepted one this morning. So we're a pretty big school, or a pretty big academy support center. We're a small school, but we're a big academy support center. So I can help you with that, Dr. Ogun. All right, any other questions? All right, let's just real quickly, I'm not going to spend a lot of time on the application layer, because this is where most people already have the most understanding. We've gone all the way up the OSI model. We're at the very top, or at the TCP/IP model, because we're at the top of the TCP/IP model too. We can see here we're at the application layer. And remember, the TCP/IP model combines the functions of the application, presentation, and session layer in what is called the application layer of the TCP/IP model. The applications that are part of the TCP/IP protocol suite, some of them, not all of them by any means, but the ones mentioned here are DNS, HTTP, SMTP, POP, DHCP, FTP, and IMAP. Of course, there's also secure FTP. There's also others that exist at this level. There's trivial file transfer protocol, TFTP, that's not mentioned here, but these are the ones that they're basically looking at. Now, one of the things that is very hard to understand is what is the function of the presentation layer. And really, that is just to put things into intermediary formats or to known formats. So when we see things like movie files, JPEGs, GIFs, PNGs, all of those are what we would consider to be presentation layer standards. Also, many people would say that the presentation layer is responsible for encryption and decryption or compression of information at those layers. We honestly, in the real world, don't deal much with the presentation or the session layer, because the session layer just maintains dialogue between applications. So it's something that's built into most applications into the way the applications work. So for instance, if you go to do a web page, open up a web page. So if I go to contenthub.netacad, you do a GET request to get a page, and then that page is returned to you. All of that would be handled by the application layer. One of the ones that's very common and one that is extremely useful and necessary for the internet is DNS, the domain name system. DNS uses both TCP and UDP port 53, and it translates IP addresses into domain names, or domain names into IP addresses is really what it does. It does domain names to IP addresses. This makes it possible for us to put in www.cisco.com or netacad.com. It's also one of the places that was not designed with security in mind to begin with. And as a result, it is fairly susceptible to security issues. DHCP was built out of an old protocol called BootP, which was used by diskless workstations to boot up and get IP addresses based upon their MAC addresses. Now we use DHCP, which uses UDP port 68 and 67, and those are to dynamically assign IP addresses. Email uses SMTP, POP3, and IMAP. SMTP is to allow email to other servers, so between servers, TCP 25. POP3 is a client protocol that is designed to download all the emails to a local mail application. IMAP is designed to allow you the option of leaving mail on the server. However, it can also be set up to download email locally. So be careful with your IMAP client. Sometimes by default, the IMAP clients still download them locally. You need to set your options to maintain a copy on the server. FTP and TFTP, these are our two file transfer protocols that are part of TCP/IP protocol stack. You may also know of Secure Copy, which is more of a Linux base, but it's still also another one that we use. But FTP uses 20 and 21 TCP. TFTP uses UDP 69. We use TFTP quite often in our networking world to upload files and configurations and iOS images to our devices. So we actually do use TFTP quite a bit in the world of networking. And last but not least are HTTP and HTTPS. And these are TCP port 80 by default, typically port 80, and 8080, and then TCP and UDP 443 for HTTPS. Let's look at some of the models for how we can do. First off is the client server model. This is our server-based networks. Now, when we talk about server-based networks, one of the things we need to talk about is pull up Notepad here. So a server-based network. One thing is it is more secure. Why? Why are server-based networks more secure than peer-to-peer or our normal our work group-based networks? You might know why server-based networks are more secure.
You have the firewall.
You have firewalls. Yep, you can still have a firewall in a work group-based network. You can still have a firewall at the edge, but typically in a server-based network, you do have more robust networking capabilities. How about the fact that you have centralized security? In other words, we've got this server here. This server that we have has usually some type of database that contains usernames and passwords that we authenticate against so that we can go and download files and folders and things off of emails, whatever, off of that server. So we have a more centralized security. They can be bigger, okay? So typically if it's 10 plus devices or 10 plus hosts, we typically try to make it a server-based network. Not always, but typically. The other thing, what about this? It's more expensive to do a server-based network. Does anybody know why? Any of you bought a server lately? Anybody ordered a server in the past 3 months?
Server is more expensive than any other.
Much more expensive. I have bought probably in the past year 25 servers, and ranging in price from $17,000 to $25,000. So more expensive. The servers are expensive, and they're also getting very hard to get because of the chip shortage. The other thing that's expensive is administrators. We don't work for cheap, folks. We like to get paid. So it costs more on a server-based network because it's more expensive. I will say this though, if you want security, if you want any type of security and centralized management, you're going to have a server-based network. I have put in server-based networks in places as small as 5 computers. And it was because it was a law firm and they needed centralized security and they needed centralized logging and log on. So just because it's a small environment doesn't automatically mean it will not be server-based. However, if it is small, you can have what is called a peer-to-peer network. I can type here. Oh, I can't type. It is less secure because there is no centralized security. There's no centralized admin. Okay. It is less expensive though, because you can just take a group of 4 or 5 machines, hook them all together, share files off of them, and it's much less expensive. But there's no centralized security and there's very little security overall. You also don't have any there's no centralized accountants. So you end up with having to have an account on every single device in order to access any type of information on that device. So with a peer-to-peer network, it's usually 10, I'd say 9 or less, actually, 9 or less devices or hosts. Okay. But there are places where peer-to-peer makes sense. If it's a very small office, there's only 2 PCs, it may be that a peer-to-peer network makes sense. So here's a peer-to-peer network where we have 2 PCs connected together on a switch. And then that one PC, peer 2, is connected to the printer. And then you would have to allow peer 1 would have to have some type of login ability on peer 2, or this printer would have to be shared so that anybody can access it. And then peer 1 could print to the printer off of peer 2. This is becoming less and less common even in peer-to-peer networks though, because most of our printers today are network-based printers. So we just hook the printer directly to the switch, and then both devices could print to it. So that's much more common now than this. This used to be what we did. We'd hook a printer to a PC and then share it off of a PC back when printers didn't have their own built-in network cards. But now most of them have network cards. So. Questions about a server-based or client-server model, which is what they call it, a client-server. I call it a server-based network, versus a peer-to-peer network.
The server, do you have a recommendation of the type of server that you have more reliability on it?
I do have one that I can give you that we use in our net labs. It's a pretty high-end server. I mean, it really is a very high-end server that we use because we serve so many virtual machines off of them. So yes, I can give you one of those. If you'll email me, we'll pull the stats for you, or pull the specifications and send them to you so you can see them. We use Dell servers right now. That's what we've kind of settled on. And we've been very, knock on wood, very pleased with them because of the price performance that we get off of them. Yes, I can definitely share that with you if you would like it. So just email me and I'll send it to you. I'll pull a document for you.
Okay.
Now I will say this, remember, we're putting this on the back end of our NetLab system. So it's the servers we're buying are really beefy servers. They're designed, with huge amount of RAM. We don't do quite as much local hard drive space because we use a couple network attached storage devices. But we do have a large amount of RAM and large number of processors and processor cores.
Let me
Great.
ask you another question
Yeah.
on HTTP and HTTPS,
Okay.
because different companies switching to the secure, and sometimes when I'm trying to get to HTTPS, I see that they're still using the HTTP.
Okay. Let me get there in just 1 second. Let's look just real quickly at these common peer-to-peer applications. BitTorrent, Direct Connect, Freenet. Some networks are blocking BitTorrent, but BitTorrent also has good uses. It's not just for downloading illegal movies and things. BitTorrent is used by a lot of open source to allow you to download from different repositories, different items. So you have to be careful with just completely blocking BitTorrent. So let's talk a little bit about HTTP. So HTTP is the web protocol. So it's how we connect to web servers and how we get information off of web servers. HTTP is not secure, so it's not sending your information encrypted. HTTPS does encrypt the information. Now, Dr. Ogden, what was your question about HTTP and HTTPS? Because what's normally happening when you connect with HTTPS, you end up with an encrypted data stream with TLS and SSL. And then that way, it actually, what happens is the public key is shared. Oop, he got dropped. The public key is shared, and you use that public key to encrypt, and then the private key is used to decrypt so that your information is not able to be decrypted across the internet. He dropped off. I don't know. Any questions on HTTP, HTTPS? Without this, the internet wouldn't work. 100% wouldn't work. Our email protocols, you'll notice that SMTP is used between servers to talk to one another, typically. It's also used by the clients to send things up to an email server to be sent. And then IMAP and POP are the two that are used by typically our clients to connect to our mail servers. And that's the kind of thing you will see on the chapter exam. You're not even going to see much of this on the real exam, but it's important your students understand that SMTP is TCP 25 because you're going to need to know that for future access control lists when we write those, or that POP3 is TCP 110 and IMAP is TCP 143, so that we do know what these are. Okay, so you can see here when you send an email, you'll use SMTP to send it to the server. Servers use SMTP to send them between one another, and then the email can be delivered using either POP or IMAP, either one. So you're sending with SMTP and receiving with POP3 or IMAP. DNS, super important. One of the most important things on the internet, because without it, we would not be able to easily get to different sites. You'll notice that in DNS, we have what are called fully qualified domain names. So this www.cisco.com has an understanding that there's a dot at the end of com, which would be the root. And so you've got your upper level, and let's go up here and look at this. We got your root, which is the dot level. Then above that, you've got, below that, excuse me, you've got all of the top level domains like .net, .edu, .org, .mil. Now we've got countries like .au, which is Australia, .jp, Japan. And then second level domains come below the top level domain. So you purchase a second level domain. So Cisco purchased cisco.com. So Cisco is a second level domain. And then at Cisco, they have all of their servers, and they have what are called A records or host records for those servers. Now, having said that, the way that host records now work, there's all kinds of ways to make sure that the A record is not just to a single device. It's actually to a group of devices. So when you connect to www.cisco.com, you connect to a large pool of web servers that are available. We also have AAA or Quad A, which is those Quad A's are used by IPv6, used for IPv6 for host records. An MX record is used by your mail exchange. This is something that if you ever have to change your mail server or your mail exchange record, can be a pain because it takes a little while for things to propagate through DNS. So you can end up with your mail going down for a short amount of time. But you'll notice that all of these top level domains, we purchase from those and we get our second level domains, and then we actually have our individual servers inside of here. There's also a thing called an alias. So you can give another name to a server instead of just an A record. So you can point to, or excuse me, a C name, also a canonical name that you can do the same thing with. We would have been a lot better off in the world if we would have had some of our top level domains. Like, honestly, there's a new one called .xxx. If when things were going on, all pornography could have been put on that one top level domain, we could all just block a single domain and have all that blocked by our networks. Unfortunately, that didn't take place, but it is a top level domain now that we can block, which is a good thing. NS lookup is a special command that allows you to look at how DNS is set up on your client, and also to actually do queries to find out what IP address is associated with a fully qualified domain name. So in this case, they've done an NS lookup and they have figured out what the IP address is for Cisco.netacad.net. The funny thing is, though, because of the round robin nature of the way servers are presented, you could possibly do the lookup 2 times, one right after the other, and get 2 different IP addresses. Or that IP address is being serviced by multiple different servers, so that there's not just a single server sitting out there holding Cisco.com or netacad.com. Any questions about DHCP? I do have a little mnemonic to help you remember this. I call it my good old Aunt Dora, D-O-R-A, discover, offer, request, acknowledgement. So good old Aunt Dora. When a client boots up, it sends out, broadcasts a DHCP discover. The server sends back a DHCP offer and says, hey, here's an IP address you can use. The client sends back a request, says that's a mighty fine looking IP address. Do you mind if I use it? And then finally, the DHCP server will acknowledge that client request. One of the things that is part of this request you will learn is what are called scope options, or different options. One of those options is how long the address is valid for. Another option is the default gateway, DNS server. Those types of items are all options. That is part of this offer that comes back from the DHCP server, and it is something that you set up as part of your scopes when you create them. When we get into later classes, later CCNA 2, CCNA 3, you're actually going to learn how to create IPv4 and IPv6 scopes for DHCP so that you can hand out IP addresses automatically off of a Cisco device. Having said that, we typically hand those addresses off through a Windows server, or because it's so much easier to create DHCP scopes on a Windows server than it is on a Cisco device. Questions about DHCP? No questions? Last but not least, let's look at some of our file sharing services, such as FTP. FTP does have 2 different ports it uses, 20 and 21, control and data. So when a client connects, the data connects, and then to get the data is sent on a different port. So it's a little different because the control traffic uses 21 and the data is transferred using port 20. That used to cause problems for our firewalls because it looked like something was trying to hop ports. They pretty much all understand that now. You can also use a type of FTP which will send everything on one port instead of using 2 different ports. So that is something that is possible. But right now, all of our firewalls understand FTP, so we don't really have to worry about it. SMB is a type of file transfer or file sharing program that is used by Windows operating systems, but it also, by the way, you can set this up on a Linux box. It does work on Linux too, SMB. So when you connect to a Windows machine and connect to a file service, you're using SMB. Now it's a little different because it uses, instead of SMB, it uses DNS and SMB. So it's SMB still under the hood, but it's a little bit different now because of the fact that it's been modified to work with the Windows newer operating system. So it's not fully SMB, it's SMB over TCP/IP. So by the way, SMB is called Samba on Linux boxes. So if you've ever connected to a Samba share, or if you've ever configured a Samba share, you've been configuring the SMB. Any questions on TCP, on the application layer or any of these TCP IP protocols that we've discussed at the application layer? We really only have 2 more items to go over, and one of these I've already kind of gone over, which is setting up SSH on a device. I will go over module 16 next week. I will also go over again the process of doing SSH in our class lab on Thursday. But really, we're down to the point now of really just trying to finish up and get done with the class. I'm going to be here Thursday, Lord willing, as long as I don't have any issues. I've been having some health issues, but they've kind of settled down a little bit, thankfully, knock on wood. But otherwise, I plan to be here on Thursday to go over SSH and how to harden your device security, because one of the things we do talk about is requiring certain length passwords and also setting up your device so you can't access it with any way except for SSH. So I'm going to stop sharing. I'm going to turn on my camera. And do you have any questions for me? Any questions about the class? Any questions about anything we've gone over? We've got roughly about 2 weeks, a little over, right at 2 weeks to get this done. So I feel confident that we can do it. I will catch up on grading tomorrow. Today I was swamped with trying to get schools helped to move over to new ASC. But I'm gonna catch up on grading tomorrow. So if you've turned some stuff in that hasn't been graded, I'll get to that tomorrow. So I'm going all the way back to the very first chapter and checking to make sure anybody's left anything in there that I can catch up with it. Are there any other questions about our course or our course of action? What we're planning on doing? Any of you going to offer a CCNA 1 class in the fall? Any of you planning to do that?
If we do it, it's internally to our staff.
Okay, well, that's fine. That's no problem at all. That would be a good way. Actually, that'd be a really good way to do it. That way you could, learn how it works, how everything, and even that way your same offer stands for your staff. If they need access to our NetLabs, we'll do that for the class too, so that they'll be able to see how NetLabs works. So, and not all schools are going to have NetLabs. Obviously, I hope you watched my video last week, and I know the video quality wasn't great. But if you will go review last week's lab class, I walked through our lab and showed you our lab and how we do it. And so give you some ideas on how you can do your local lab. I do know Cisco is working on getting some bundles to schools who are academies or have been academies. So I know they're working on that. All right, well, folks, that's all I have for today.
What are the correct, I'll call it correct number of weeks the course should be?
That is a good question. There is no absolute correct answer to that. The one rule is this: you cannot do it in less than 2 weeks. I think that's the rule that Cisco goes with for the academy. And the reason being is they don't want us competing with their corporate training partners. We typically teach this class 8 to 10 weeks minimum. Okay, I would say that for me, a good time frame is typically 10 weeks, 10 to a minimum 10 weeks. Most schools today are teaching it now. We do teach in 8-week blocks to our students here locally, but when we do that, we meet 4 days a week for 2.5 hours. So we're doing 10 hours of classwork per week for 10 weeks. So it's 80 hours. So I would say at a university level, I would make it a full semester course if I was going to teach it at a university level, because it can easily fit that, no doubt. But the only requirement for us, again, is no less than 2 weeks, so that you're not competing with the corporate training centers. Otherwise, it's, it really depends on the school. We've seen typically, if you do 8 weeks, you need to do it 10 hours a week and have a very intense class. If you're going to teach it over a longer block, then minimum 10 to 16 weeks is what we typically suggest.
Yeah, I'm looking at longer, because if we're doing it with staff, we have to fit it in their schedules. And I didn't know if there was you must finish in, 10 weeks or 12 weeks or whatever.
The only absolute time limit is 1 year. Classes can stay open in the system for 1 year. That's the absolute maximum that we have. But other than that, there is no absolute maximum that we typically say. Which is one of the reasons I really like the program, is it's made to fit into your program the way you need to teach it to your students. And that's where Cisco has really said, we are not going to tell educators how to educate. We expect you to know, you'll do what's right for your students. We're going to provide you with high quality materials, good labs, good content, and then you use that in your environment the way that's best for you. Good question. Excellent question. Anybody else? All right, I'm gonna stop.